Okay, this is in section 1.6, number 11, which is assigned as one of your homework problems. And I had a couple of questions from students, and I figured, well, when there's more than one, I think it's a good idea to just reply via video because other students may have the same question. So here, this is this is a differential equation given, and you're using the substitution method. So I went ahead and put dot 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 since it is a homework problem, but this dot 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 part is not too bad. But eventually you should end up with this equation, and notice that this side is not the hard part, right? This is just the natural log of x plus my constant of integration. And that doesn't look nice. Let's make it look nice. Plus c. Okay, so this is the integral, this is the integrand that you want to integrate. And here you're actually going to use partial fractions because if you, so let's see, I'm going to go ahead and rewrite the integral. So 1 minus v squared, and I can factor out a v from the denominator, and I'm left with 1 plus v squared. Okay, so here is where you need to notice that you're going to use partial fractions because there's no integral, there's no table of integrals for this guy. And the key is the fact that it's a product. And so anytime you have a product in the denominator, whether it's a product of linear factors or quadratic factors, you can you can break it up into you can decompose the function into partial fractions or pieces of fractions that you'll see. So in this case, so again, I'm going to work with this guy. This is what I'm basically doing. I'm not going to solve the whole problem, but this will help you finish the problem. Okay, so this is my integrand here. So I have 1 minus v squared over v times the quantity 1 plus v squared. Okay, so I want to decompose this fraction into partial fractions, where partial has nothing to do with the partial derivative here. It's literally you want pieces, right? You want to break it up. So this is the decomposition part, and you write your factors, right? You have v, and then you have, well, 1 plus v squared or v squared plus 1. The order doesn't matter. And usually you want, you are going to find these two coefficients. Now, the coefficients depend on what type of factor you have. So this is a linear factor. I mean, that's really just a line, right? The degree is 1. So let's see, a different color here. So I'm going to just call that A. Now, because this factor, whoops, I didn't want to do blue, but because this is a quadratic factor, right? The highest degree is 2. I mean, we want to put a coefficient, but the factor in the numerator has to be a degree. It has to be 1 less degree than the factor in the denominator. So 1 less than 2 is a 1. So I'm just going to write bx, right? Because there's a 1 here. Okay, so this is, I mean, again, a good, hopefully a review. And if I combine these fractions, right, if I go back and, I mean, this is just from, right, if you're an Algebra 1 student and you want to know how to add fractions, right, you're just going to get the common denominator, and then this is going to be v squared plus 1 plus b vx1. So I'm just going to rewrite the left-hand side. And then notice we have, this is a proportion, we have the denominators are the same. So if the denominators are the same, then the numerators must be equal. So we equate the numerator expressions. So we have 1 minus v squared equals the following, plus bvx1. So the goal is to solve for, well, we want to find what a and b are, and they're going to be constants, numerical coefficients. And let's see, what color do I want to use? Let's go back to white. Okay, so this is the strategy. You can pick any v, but let's keep it simple. If v is 0, then what relationship do I get? Well, the reason I'm letting v be 0 is because if v is 0 here, then that means this is gone, which is great because then that's a big 0. But I'm inputting 0 into this equation. So if I input 0 here, well, 1 minus 0, that's just 1, equals, right? And then I'm inputting 0 here, so that's really 0 plus 1, so you just get a. So a is 1. Okay, so I found my a. Now I want to find my b, so now I'm going to let v be 1. Now usually, I mean, when it's a quadratic factor, it's a little more complex, not that complex, but I mean, I can, if I ask you to give me a value such that when I insert the value for v, right, v squared plus 1 is going to be 0, it's not going to be 0. It's never going to be 0. I mean, it's a nice polynomial function. So if v is equal to you can let v be negative 1. That's actually going to be the same thing. But if v is 1, then, right, then again I'm inserting this guy, and that's just 1 squared plus 1 is 2, so I get 2a. And then I'm inserting my, not there, I'm inserting my, yes, in my v. So I get plus b, let's see, v plus bv. And I'm not sure why I put the x there. Sorry about that. There is no x. I'm thinking of linear factors in terms of x, but which that's what we usually do. But since we're using the substitution method, my variable is v. So sorry about that. There is no b there. Sorry, that was an error by me, so ignore that v. Okay, so then we're left with our b, but now, I mean, we have this nice, well, actually equals, and then if I insert my 1 in here, right, I get 1 minus 1, which is 0. And then we know what a is, right? A is 1, so it's just 2 plus b equals 0. Therefore, b must be negative 2. So I found my a and b, and let's just plug it back in. That's what we are doing. And again, let me erase this part. This is b. That should really be a v, bv. BV, BV, okay. So let's go back to, let me get my white here. Okay, so I have the integral of a, well, my a is 1, let me get my white again, over v plus, what's my b? Well, my b is negative 2, and again, my variable is v. All over v squared plus 1, right, and that's with respect to dv. So now, I mean, the property of integrals, I can break this up into two integrals, plus the integral, well, technically we can write minus, since it's, well, you can even write the minus 2 out, why not? And then we get v over v squared plus, and actually, I do want to keep my 2 out, and you'll see why. I can't take out that negative 2, but I actually don't want to because, let's see, I'm going to get minus the integral of 2 v over v squared plus 1 dv. Okay, now when we integrate, this is very easy, right? That's the natural log of v. And then this guy, and that's minus, not equals, right? This guy we've seen before, right? If we take the derivative of v squared plus 1, the derivative is 2v. So, I mean, we have our, f prime of v over f of v. So this is the natural log of f of v, or f of x. So I get v squared plus 1, and of course my constant of integration. So that's basically it. That's how you, this is right one side, and remember the right hand side was this guy, and then you can exponentiate both sides, right? We have nice natural logarithms. And it's great because we can use properties of logarithms, which simplifies the expression. So again, this is partial fraction decomposition. I also sent a handout of just kind of guidelines of partial fractions, especially when these are linear factors, it's very easy. When it's a quadratic factor, you just have to make sure to have a linear factor on top. So again, this is a linear factor, and right, this guy is my quadratic factor. Okay, so hopefully that helps. Again, we'll definitely be doing this a lot in chapter 2.